All right, today we're going to tear down this gorgeous animated UI spinner. I mean, look at it. You might think it's super complex, right? Well, it's built entirely from code for the B4X platform, and we're about to figure out exactly how it ticks.
And there it is. Just watch it go. You've got these three rings all spinning concentrically, but notice how they're all moving at different speeds? That's what gives it that really slick professional feel. It's the perfect way to tell a user, hey, hang on, we're working on it.
But here's the kicker, and this is what really blew my mind. That's not a GIF, it's not a video file. Every single frame of that animation is being drawn, live, right now, just with code. So the real question is, how on earth did they pull that off?
Okay, so before we dive deep into the crazy animation code, let's start with the basics. Let's look at it from a developer's point of view. How easy is it to actually use this thing and make it your own? And right away, you can see this thing was built with developers in mind. Look at this. Straight from the visual designer, you can tweak all the important stuff. You want to change the size? Done. The color for each individual ring? Easy. Even the thickness of the lines, the stroke width, it's all right there, super simple to customize. So how does that work behind the scenes? Well, it's pretty clean. When you say change the color one property in the designer, it's just calling a simple function called setColor1 in the code. This is great design because it keeps things separate. You just have to worry about what you want to change, not how the drawing actually happens. We'll get to the how in a bit.
All right, customization is cool and all, but now it's time for the fun part. Let's pop the hood and see what this thing is really made of. What's the core structure?
You know, the basic setup is actually way simpler than you'd think. It all starts with a base panel, and then think of it like stacking 3 sheets of clear glass right on top of it. Those are 3 transparent panels, one for each ring, so each ring gets its own private little canvas to be drawn on. Super clever.
Okay, but wait a second. How do they get the rings to be perfectly, and I mean perfectly, centered? I found this little comment in the code, and it's the whole secret. The trick is that all 3 of those panels are the exact same size and centered right on top of each other. The different ring sizes don't come from different sized panels. They just draw bigger or smaller circles on each of those identical canvases. It's just a really smart, elegant way to solve the problem.
And if you're a developer who just wants to use this, it couldn't be easier. Seriously, it's 3 steps. You create the spinner, you stick it onto something like a full screen overlay, and then you just tell it when to .show and .hide. That's it. So simple.
Okay, so we've got the skeleton, the structure, but a spinner's got to spin, right? So what makes it move? Let's get to the real engine of this thing, the animation loop.
Believe it or not, the entire animation is powered by a simple timer. That's it. It's set to tick every 16 milliseconds. And every single time it ticks, it just updates the position of the rings a tiny little bit. And that 16 millisecond number, that's not random. That's the magic number to hit about 60 frames per second, which is why everything looks so buttery smooth.
So what happens on each tick? Well, the code nudges each ring forward just a little bit, and these numbers, pulled right from the code's comments, show the secret sauce. See how each ring moves by a slightly different angle? Ring 2 is kind of lazy. It moves the slowest. But ring 3 is really hustling. It's the fastest. That difference in speed is what gives it that awesome, complex-looking motion where they seem to dance around each other.
All right, we've got the structure, we've got the motion, but there's one last piece to this puzzle. And honestly, it might be the cleverest part. How does a computer actually draw a perfect smooth curve? This is where we go from theory to actual pixels on the screen.
The main tool for the job is something called a B4 path. The easiest way to think about it is like a connect the dots puzzle for the computer. You give it a series of points, and it draws lines between them to build a shape. In our case, that shape is the arc for each ring.
And the real workhorse here is a custom function called createArcPath. Its whole job is to be a translator. It takes abstract ideas we understand, like a center point, a radius, an angle, and turns them into that series of connect the dots points that the B4X path needs to actually draw something.
So how does it draw that perfect curve? Well, here's the big secret. It doesn't. It's a trick. The goal is to look like a smooth arc. The method is to actually draw a bunch of tiny little straight lines all connected together. If you make the line small enough, your brain just fills in the gaps and sees a perfect curve. It's a classic illusion in computer graphics, and it works beautifully. So how many of these tiny little lines does it take to fool our eyes? 100? 1,000? No, get this. It's just 12. That's it. Each of those smooth-looking arcs is really just 12 straight lines chained together. It's just amazing how efficient that is. You get a perfect visual result with a tiny amount of work.
So when we put it all together, what are the big takeaways here? First, really complex-looking UI can be built from super simple parts, just layered cleverly. Second, you don't always need some giant animation library. A basic timer and a little bit of math can create something incredibly smooth. Third, and this is a big one, those beautiful curves you see on screen, they're often just an illusion made of tiny straight lines. And finally, the best code separates the easy-to-change settings from the core engine that makes it all run.
So that just leaves one last question for you. We've seen how these basic, almost simple techniques, layered panels, a timer, and a clever drawing trick, can come together to create something this polished. It makes you wonder, right? What else could you build using these same fundamental ideas?